All right, Matthew. So, apologize I can't be in class today, but this is a quick review, right? Sections 1 to 1-3 we have done. Okay. So, the first topic we had talked about was combining like terms and simplifying expressions. And if you remember, combining like terms, we put shapes around like terms. So 8x squared goes by itself because there's no other 8x squareds. So I'm going to bring that over here, 8x squared. Then negative 3x plus 9x, negative 3 plus 9 is plus 6x. And then negative 2 minus 5 would give me minus 7. Okay. Now the next one is the distributive property where everything inside the quantity gets multiplied by the 4. So 4 times 3x is 12x. Then 4 times negative 2 is negative 8. Therefore, I subtract 8. Now the next one's distributive property again. I'm going to go ahead and distribute, but negative 3x times 2x, and negative times a positive is negative 6. X times x is x squared. Then negative 3x times 4 is negative, so we're minus 12x, and we're done. Okay, the next thing we're going to do is the first thing we have to do here is distribute. So I'm going to distribute the 5 to get 10x. Then 5 times negative 3 is minus 15 plus 24x plus 6. Then I look to combine like terms. So I notice these terms can be combined. 10x plus 24x is 34x. And then negative 15 plus 6 is negative 9, so minus 9. And when we multiply these binomials together, x times x is x squared. X times negative 7 is minus 7x. 3 times x is plus 3x. And then 3 times negative 7 is negative 21. When I combine like terms, I get x squared. These two middle terms can be combined. Negative 7x plus 3x is, that's minus 4x. And then minus 21. So the next one, 2x times 3x is 6x squared. Then 2x times negative 5 is minus 10x. Negative 3 times 3x is minus 9x. Negative 3 times negative 5 is positive 15, so plus 15. So 6x squared minus 19x when I combine plus 15. Okay. So the next one, right, is evaluating functions. So remember, we have three functions here, and the names are f, g, and h. So when I go to evaluate g of 4, I know I'm going to use function g, and everywhere I see an x, I'm going to replace it with a 4. So 4 times 2 to the 4th power. And then if I can either put that in the calculator, or I can go ahead and simplify the exponent first. So 4 times 2 to the 4th power is 16. 4 times 16 is 64. Now, h of 3, right, is going to be 2 times 3 squared minus 3 times 2 plus 5. So 3 squared is 9. 2 times 9 is 18. Negative 3 times 2 is minus 6 plus 5. 18 minus 6 is 12. And then 12 plus 5 is 17. Again, you can plug that in the calculator if you'd like. Now, if I evaluate f of 3 plus g of 1, first thing I'm going to do is evaluate f of 3, right? And if I do that, negative 2 times 3 minus 3 plus 4 gives me negative 2 times 0 plus 4, which is 0 plus 4. That would give me 4. Plus g of 1. Well, 4 times 2 to the 1st power gives me 4 times 2, which is 8. 4 plus 8 is 12. Now to the important things, okay? Now remember, we have three functions we know now, right? The first function that we've talked about is linear. And linear functions, right, are in the form of y equals mx plus b, okay, where x is to the first power. Then we had exponential, which is y equals a times b to some exponent. And the last now is quadratic, okay? And anytime you get a quadratic, it would be something like ax squared plus bx plus c. The x squared is what makes it quadratic, right? So right away here, if I give you f of x equals 4 to times 3 to the x, right away we know that that's exponential. If we had to write the recursive, if I plug 1 in here, right, what is f of 1? Well, 4 times 3 to the first power gives me 4 times 3, which is 12. And now I would get my previous term. And what am I multiplying by each time? What's my common ratio? 3. Okay. The next one, right now I see x times x plus 4. If I was to simplify this, x times x is x squared plus 4x. This x squared right here tells me it's quadratic. I'm not going to worry about having you guys do the recursive for the quadratic. Just know how to recognize a quadratic. And the next one, if I look, this is in the form of m times the quantity x minus x1 plus y1. Since you have a slope and an ordered pair and x is raised to the first, you know it's linear. So now my recursive here would be f of 0 equals, actually let's do f of 1. It doesn't matter which one you do. Negative 9 times 1 minus 1 plus 4 gives me negative 9 times 0 plus 4, which gives you 0 plus 4, which is 4. And therefore, f of x equals my previous term. Since my slope or rate of change is minus 9, it's minus 9. Okay. Next one. Use the following graph to determine d of t with respect of t. Use this graph to answer the questions. What is d of 4? If I go to 4 on the x-axis and I go up, d of 4 is 5 miles. Okay. How long does it take him to get to 11 hours? Well, if I follow this graph up to a distance of 11 miles, how far or how long did it take him? Took him 5 hours. How long did it take him to get home after he reached his destination? Well, his destination was up here, and from 5 hours to 10, it took him another 5 hours to get home. And if I had to interpret d of 3 equals 4, right, what that means t is 3, d is 4. And if I interpret this, it's after 3 hours, he traveled, right, 4 miles. Okay, so pretty straightforward. Now to recognize linear, exponential, quadratic, or neither, right, we look for common ratio, common difference, or second common difference. If you don't have either of those, it's neither. Only write the explicit recursive for linear and exponential, okay? You don't have to do quadratic. So here, if I look, right, what is happening here? I'm going up 4. Here I went up 10. Here I went up 14. Here I went up 18. Is that a common ratio? No, it's not a common difference. What it is it's a second difference, because the difference here is up 4, up 4, up 4. And if it has a common second difference, it tells you it's quadratic. Now the next one, right? If I look at the pattern, okay, what do I have to multiply 6 by to get 2? I'd have to multiply by 2. Is 12 times 2 going to give me 32? No. If I look at adding here, 6 plus 6, right? 12 plus 20 would give me 32. 32 plus 18, right, would give me 50. Is there any pattern here? No. So this would be neither. Okay. The next one you should be able to recognize right away. Right away, up 2, right, up 2. Therefore, this is linear because it has a first common difference. My explicit rule, since I'm giving the value of x when it's 0, or value of y when x is 0, I know it's going to be f of x equals my rate of change, or common difference, is 2 times x. And what did I start with? Plus 6. You could also do, if you wanted to, 2 times x minus 0 plus 6. I'll take either of those. Okay, the recursive, you start at f of 0 equals 6. Then f of x equals f of x minus 1, right, plus 2. All right. The next one, you should recognize what's happening here. 3, 9, 27, 81, 243. You are multiplying by 3 each time, which means it's exponential. Your explicit, again, you're given the value of y when x is 0. Okay, and if that happens, my explicit rule would be f of x equals my starting amount times my common ratio to the x power. Recursive, f of 0 equals 3. Then f of x equals 3 times, f of x minus 1 times 3. Okay. All right. This next example, real quick. Toothpicks were used to create, right, the following diagrams below. Determine if the number of toothpicks used represents a function that is linear, exponential, or quadratic. Okay, so right away, you have first stage, how many toothpicks did you have? 3. Second stage, you had 1, 2, 3, 4, 5. In the third stage, you had 1, 2, 3, 4, 5, 6, 7. In the fourth, you had 1, 2, 3, 4, 5, 6, 7, 8, 9. Therefore, when I look at this right away, right, if I made a table, it would go up by what each time? It would go up by 2, which makes it linear. Now, the recursive rule would be, how many do I have in my first diagram? I have 3. And then f of x is equal to, what am I doing to the previous term each time? I'm adding 2. Now, my explicit rule, remember, I'm not given the number of toothpicks in the 0 diagram. Therefore, my rate of change is 2 times x minus 1 plus 3. Remember, x1, y1. How many toothpicks would be in stage 5? That would be 11. Okay, so do me a favor. Go ahead and use this to help you with the homework.